So you get things from viewers and patients. This whole topic came up from 147 degrees west. I believe our old friend, or maybe young friend, I don't know, our friend is in Alaska, I believe you mentioned. So thank you very much for pointing out. We haven't talked about the glycocalyx. What is glycocalyx? Let's break it down real quick. Glyco means sugar, calyx means a bunch of, sort of a fibrous structure like a sponge. So why is this important? Well, here's the short version. If you want to listen to 15 or seconds or a minute and then leave, the short version is it's these hairy things that stick out into the inside of the artery wall, and they have a heck of a lot to do with transport of things in the blood to the tissue. They have a lot to do with selective permeability or lack of transport. They have a lot to do with the space between the blood and the vessels. And you know, it's not just blood vessels that have this. The gut has this. You remember tight junctions? This is a very similar issue. There's a glycocalyx in the gut, and tight junctions are involved in this process as well, as in haptoglobin 2. You also see damage to this. Look at this. So again, that was the quick summary. For those of you who are interested in a little bit more detail, now we'll talk a little bit more about detail, maybe from 30,000 feet down to 10,000 feet. So how is this information becoming available now? STORM, Stochastic Optical Reconstruction Microscopy. And I used to know. I was curious about the word stochastic, but I don't even remember it anymore. I'm just very interested and excited to share some about this topic. So using this, they're able to take pictures, which they couldn't take with routine microscopy in the past because it's just too small. That's again, a STORM image. Well, let me go back. There's just been a lot of information coming out. This is the Yale Journal of Biological Medicine last year, 2018. Again, just tons and tons of stuff coming out. In this image, you've got the endothelium here. These are the endothelial cells. You see this little pocket. We'll show a diagram of a pocket in just a minute. And then you've got this hairy glycocalyx. Again, I think these images came from the Yale STORM study. Again, the cross-section of an artery, and then that glycocalyx. Not a very healthy glycocalyx here, huh? And I think this green one is just more of like a isotope showing that through radio imaging. Remember I said we were going to talk about, or I was going to show you an example of a capillaries? Well, no, it was up here, wasn't it? Yeah, a capillaries. There, you see it in the actual picture, and here you see a diagram. Now, what is this? Let's get oriented here. This is the inside of the endothelial cell. This is the inside the lumen, or where the blood is actually flowing. And these are all of those little fibers that make up the glycocalyx. And as you can see, we are down to a molecular level. That's why we never saw it before under routine microscopy. It's just too small. And here you see a glycoprotein. I think that's sialic acid. No, I'm not sure what kind of acid that is. But again, different types of glycocalyces, fibers, which have several uses. We'll talk about those in just a minute. Let's orient on these images again very quickly. This is the endothelium. This is that cell wall. These are some of the receptors in the cell wall. And then again, this is glycocalyx. Glycocalyx fibers coming out into where the blood is flowing. these three gradients also show flow. You know, you get most of your flow out where the glycocalyx is not actually reaching. In this image, out in here, you're not going to get flow very well there. Same thing over here. A couple of other types of cell membrane receptors, like the insulin receptor, for example. These receptors have a major mechanism within the cell, but they have things sticking out. Quite often it's a glycocalyx fiber sticking out into the flow, and then they fit like lock and key into a molecule that's coming in, whether it's glucose to pull glucose into the cell from the blood, or insulin, which is related to that and helps activate that process, or something that locks to a hormone, or just, again, unlimited other cells in the blood. This shows that process where, again, you get shear stress here because you get blood flow, but you don't get that. The flow is much slower here. This one also shows a couple of other things. It talks about L-arginine combining with oxygen to form nitrous oxide, which then goes on to create relaxation in the media or the muscle wall. Again, flow out here, glycocalyx area here, intima area here, and media or muscle area here. And as you remember, arginine and citrulline are two things that help form nitric oxide, which in turn helps relax the muscle walls. We know that from giving nitroglycerin to people that are having angina. And bodybuilders, weightlifters use citrulline. They think that gives them a better pump. If you're having a hard time getting your head around this thing about shear and flow, just think about a river out in a marsh. You've got a river in the background, and that river is flowing pretty well. You actually have some creek-type flow here. But the deeper you get into these areas where the marsh is sticking up into the water, the slower the flow becomes. And guess what? Think about a marsh. Where do you see the crabs? Where do you see you can see some big blue crabs out in the flow and some fish out in the flow. But where you see the estuary, the tiny animals, the baby crabs, the baby, you name it. I'm not a marsh biologist. But where you see a lot of the real action going on in terms of the life of a marsh is right there, where that flow has been slowed down and there's something to hang on to. So, again, another picture of it. And speaking of functions and roles, let's just cover those very quickly. There's a mechanosensing and mechanotransduction. What is that? Remember I said a minute ago, if you're picking up things like insulin or other hormones in the blood, this glycocalyx wall area is critical for that process. If you're selective permeability, again, it helps decrease permeability to some things and maybe helps increase permeability to others. Some of that, again, due to sensing specific molecules that they want to pull in. The space between the blood and vessel wall, as you remember, and I mentioned it a couple of times, you think about tight junctions. Tight junctions are what tend to get released when we have leaky gut. I know I've switched from the vessel wall to the gut wall, but again, wanted to just get that reminder in. People think that some folks talking about lectins. What's his name? Gundry. Stephen Gundry's, they think he's crazy talking about lectins, and they always thought, so many people think leaky gut doesn't exist. It does. Now, I'm not saying I agree with everything he says. That's a whole different digression. I just wanted to come back down and make a couple of comments regarding biological processes. Tubes, whether it's an artery or a gut, have a lot of similarities. They all have a lining, a single cell lining. They all have this glycocalyx function. And this glycocalyx function is involved with tight junctions. It's involved with selective permeability. and it's involved with mechanoselection. Again, that picture that we showed earlier. Why am I showing that again? Because I didn't talk too much about this part. If you look at our channel, how often have I discussed endothelium and systemic effects and inflammation? And what happens here? There's plenty of evidence that once you start getting damage to the endothelium and inflammation, maybe that mechanism is breaking down the glycocalyx. As you remember, there was an article recently that, again, the author probably overemphasized the importance, but what they showed was it isn't that you're tearing out the endothelium during an inflammation process. It isn't that LDL seeps through areas of artery wall that have been denuded of endothelium. They're transported through the endothelium. Wonder how that's happening. So again, trying to help plant some images in your brain. If you're my generation and you're at very high risk for, or obese and at very high risk for insulin resistance, or if you, well, let's just leave it at insulin resistance, the most common cause of this type of inflammation. Think about what happens when you eat a bunch of eat some ice cream or a big plate of pasta and your blood sugar goes way up. Sugar is glycolysis. Sugar is very much involved in those little tendrils that come out. And maybe that has something to do with damaging the this glycocalyx. Very interesting topic. I love showing the pictures and hope to get some reaction. If you've made it this far, thank you for your interest. We now have a Patreon site. For the price of a Starbucks, you can help us stamp out death and disability throughout the world. So please go check it out. Thanks.